What's up, YouTube? This is my C++ Minecraft clone. We'll start with a summary for everybody that is starting watching this series for the very first time. Then with chat, we will brainstorm what we're going to do during this stream. And at the end of the stream, which is in about 3 hours, we'll do a summary what happened during this stream. So chat, this is my C++ Minecraft clone. It's made in Raylib. What's up, Alex? Alex is always first. It's made in Raylib. Here we have the menu. This is the 360-degree view. We did this screenshot, this panoramic view in the previous stream, which was Friday, I think. We have sounds. So when we press buttons, we have sounds. And currently, we only have creative mode. We have the right hand that animates when moving. It stops animating in the air, and it stops animating when we open the inventory. And in the previous stream, my favorite feature that we added is this scroll bar, chat. Look at this, chat. This is my favorite feature from the previous stream. This scroll bar, because we ran out of space. We added the bedrock and we didn't have space for it in the inventory. But now we can scroll around. So we can add as many items as we want, chat. This is my favorite feature. So we have the hotbar below us. We have sounds when we break blocks. And most importantly, we improve the particles a lot. So currently the particles are not using the whole texture. They're using just 1/4 of the entire texture. And the particles disappear after a few milliseconds. They disappear on their own. Also, the particles change even if you break different blocks. And the sound effects change. Here we have the stone sound effect. We have the dirt sound effect. Also, we added sound for the TNT. We added the fuse sound and the explosion sound. Nice. Also, we changed back to the original Minecraft texture pack. Before we have like support for texture packs. We had the bare bones texture pack, but we switched to the default Minecraft texture pack. Also, what else, chat? We have animations of the texture. We have texture animation, so even here the portal, we have the portal. So we have pistons, the pistons work as well. Here we have the piston and we can give it power and it can move objects. And we have custom block outline. Here, for example, if we put this rail here, look at how the rail has a custom block outline. It's not a 16 by 16 block. It's not 16 by 16 pixels. It's just custom height, which is cool. And even more complex shapes. We have this shape, for example. This is not a more complicated shape. We have more complicated shapes. Like the anvil. We have the anvil. So anvil has custom block outline. It has multiple blocks, chat. It has multiple blocks for the outline. And also we have crafting table. We have crafting table, which we can right click it and has a menu. It has a menu where like currently it's broken, but it's all right. Here you can place blocks. Sometimes subchunks, you can see through subchunks sometimes. Because of the first time culling, we only had one attempt at it, a single stream, so like 3 hours. We didn't manage to finish it, so that's why sometimes chunks disappear. Sometimes they disappear. Also, what else do we have, chat? What else? Yeah, we have the rails. What else do we? Yeah, we have farming. So here we can place the farmland. Let's place it like this. We have farmland and we can place water here. We can place water and we can place we can place here wheat. We can place wheat, chat. And we have F3 menu on the top left. We have the block state of the block we are highlighting. So the wheat has a block state of h. The h is a number, integer, between 0 and maybe 7. And farmland has a state. It has a property of moisture. Moisture starts from 0. This is when it's not watered. But this one, when it's 7, it's watered. And that's when the crop can start growing, and it actually grows. And I'm attempted to replicate what Minecraft does, where Minecraft picks random blocks in every subchunk. And if it randomly picks the wheat, it will grow it, if the conditions are right. So anything else that I need to tell you? Is there anything else that I should tell you? We have the chat system as well. We have a chat. So here we can do hello world. Here we have chat. We have chat. We have summon creeper. We can summon a creeper, which for now still doesn't work. The creeper doesn't work, but we have explosions. We have sounds. We can easily make it work. Oh no, it will destroy the crop. Okay, it didn't manage to destroy the crop fully. It missed the water. Brother. Anything else, chat? Yeah, we have the water. We have the water. Yeah, we have the water, chat. We have the water, which spreads around. It also prioritizes here. When there is a hole, it prioritizes it and goes inside of the hole. And that's inside of the hole. And we have structures. We also have structures, chat. So thank you for reminding me. We have structures. The tree is actually a structure. We created the tree inside of Minecraft and we saved it into a text file with this block, chat. We saved it with this block here. And here we can load structures and we can save structures. So here we can increase this like this in game. We can increase it like that. And here in this field here, in this field, we can save it and it will save it into a text file and we can give it a name and we can load it through code. We can load it through code. And we have the clouds. The clouds are not perfect because they stop generating. They don't generate infinitely and they are not 3D. That's a bit of a bummer. And also we have caves. We have two types of caves, chat. This cave is, I think it's called Pearl and Worm cave, because we pick random points. And the direction they continue those points of the cave, I use Pearl noise for it. Somebody is complaining to Alex for some. Let me remove this person. Just a ban. Don't bother Alex. If you're bothering Alex, you're removed. Alex doesn't need to be bothered with not important problems. Okay, chat, let's continue. We have two types of caves. I already showed you these are the Pearl and Worm caves. These are Pearl and Worm caves, and these are 3D noise caves. These are 3D noise caves here. They're not perfect. They're not perfect because here at the bottom they generate through the bedrock here. They show up through the bedrock, and I don't want to see this much of bedrock. I wanted to limit them, but we didn't have enough time. We had a single stream for the caves. But here, look at how they show up here, chat. Look at how they show up here. Look at how they show up here, chat. Through the terrain, you can see them. So that's basically a summary, chat. That's basically a summary. Like 10 minutes of summary is enough, chat. 10 minutes of summary is enough. And yeah, we have biomes, biome coloring, etc. We can go on a lot. Let's focus on for this stream, chat. Let's focus for this stream. So let's brainstorm what are we going to implement in this stream, chat. Let's brainstorm what we're going to implement. While we are brainstorming ideas, I'll leave here crops to grow. Like here, I'll have crops growing. Like this. Here, while we're brainstorming, we'll grow some crops. Like this, chat. Let's brainstorm some ideas, chat, while the crops are growing. Okay, so what I personally am thinking of doing during this stream is the survival inventory. Survival inventory, that's what I planned to do during this stream, but I want to hear you guys out. If you have any cool ideas, if you have an idea that I prefer more than survival, because it's a priority right now, I want to survive, we'll pick it. Mod support, if we do mod support, it will not be of more use than survival inventory. Mod support will not be of more use, but we could maybe have ores. And another important feature is mob pathfinding. Mob pathfinding. Fixing caves? No, that's not a priority. Detective Jones. Fixing caves, I'll leave them for now. We gave them enough time. The nether, if we decide to do the nether, the first thing I will do is finish the portal and to be able to teleport to a new dimension. I'll leave it here. I'll think about it. Day-night cycle. That's important. Anything else? You make inventory. Oh, and generate item mesh. Lava. How should I call it? Fix water mesh. Implement lava. You should add spectator. We already have spectator. Maybe figure out between nether, me. Fix the break animation. Break animation is part of the survival implementation. If we add survival inventory, next step is break animation, chat. Ambient occlusion in leaves, what do you mean? Third person, we have third person. I didn't show it in the summary, but we have third person. We don't have animations of the Steve, third person Steve. We could try, again, animation, animate third person Steve. Because it doesn't have animations. We could try again, we could. Fix water, show blocks in the hand. Show blocks in the hand. That should be easy. Cats and dogs. Starting menu. Oh, we can have loading menu. Like world gen loading screen. Or clusters ocean. To have see the changes so that the world is different every time. That's not a priority. Clouds are gone. They should be there, chat. They should be there. Not right now. Not right now, but they should be there. We could make endless clouds or 3D clouds. Weapons. Ability to throw items. Throw items. Throw items. Command support. I'll leave command support for a bit later. I have an idea for commands. I need some time, chat. I have a very good idea for commands. I need some time. Let me cook, chat. I need some time. Milk. Okay, we have enough options, chat. We have enough options. Falling blocks. Okay, falling blocks. And let me decide. Cow and chicken. Tick speed for commands. Fix the. Oh, to change the. Oh, change tick rate from commands. That's a good idea to slow down the game, chat. Oh, that's a good idea. That's a good idea. Crafting. Okay, we can add crafting. Crafting. You can download your world. Okay, we have enough options. We have enough options. We can create a poll. Villages, we have villages. We could improve villages. And mob spawner, we don't have pathfinding. We need pathfinding. Villages, we could improve them because they are very simple right now. Improve villages. We could do that. Health and hunger. Oh no, we got back the line problem. We got the line bug. It's not that big of a deal. We got the line bug. Can easily remove it. Should be fixed. Okay, let's create a poll. Okay, chat, let's create a poll. Create a poll. Pop out chat like this. And let's create a poll here. Start a poll. What to do today? And I need to pick 4 options. I need 4 options. So, survival inventory. Survival inventory. Survival inventory. Mob path finding. Change tick rate from game. Change tick rate. So you can slow down, speed up game. So slow, speed up in game. To be able to slow down and speed up the game. Or like tick rate. Change tick rate in game. Okay. And generate item mesh maybe. 3D clouds, throw items, falling blocks, crafting, health and hunger. Pathfinding. Pathfinding. Mob pathfinding. Mob. Finish mob pathfinding. Okay. Chat. Decide what we're going to do today. Okay, good enough. Oh, we have mob pathfinding 2 times. It's not that big of a deal. No. So chat, what are we going to implement? Mob pathfinding or mob pathfinding? That's not even okay, we'll end it. Okay, let's do survival inventory. That was brilliant. Okay, chat, so our crop already grew. Wheat is of age of 7. Okay, chat, let's try. So currently we have this creative inventory. Chat voted that we should add survival mode inventory. So like every time, let's open Minecraft. Where is my here? Let's open up Minecraft. We'll open Minecraft and we'll look at how the survival inventory looks in Minecraft for inspiration and hints on how we should implement it. Like this. Okay, we are in creative mode. In here, we'll go in survival. Okay, this is the chat. This is what we're implementing. We already have some arrows in our head. So let me think about the chat. So currently, what's the situation? Well, currently, if we compare our game with Minecraft Survival, currently our items don't have an count. Our items are infinite. We have infinite items. We can place as many as we want. This is the first major difference. Another major difference is here the inventory is limited to 3 rows and maybe 9 columns. 9 columns. 9 columns. In my game, inventory has all of the items that are infinite. We can get as many of them as we want from here. Can get as many of them as we want. And another difference is here we have Steve visible. It follows the cursor. Here we have place for armor. Here we have place for the offhand item. So here you can put shield. And here we have place for crafting. And that's it. So from where are we going to start, chat? Oh, and starts raining. Well, the easiest step we can do is get this PNG, because the menu is just the inventory is just a regular PNG. We can get this PNG and render it in game. This is the first thing we can do. The next thing we can do is to make the grid, each item to be an item slot. That's something else we can do. And to be able to place items there and remove them. That's something else we can do, chat. And then what would be a priority? And then let's first reach to that point, and then we'll decide what we're going to do, chat. Okay, so chat voted. We're going to add the inventory. Let me change the stream title so everybody knows what we're implementing. Okay, let me update it. Edit stream. Here, I'm going to call it survival inventory. That's what we're doing. Okay, chat, let's lock in. Okay, let's get this PNG image. Let's render it and let's make these items be usable. Let's do that. And let's remove this creative inventory menu. Let's remove the creative inventory menu. So when we press, when we open the inventory, to not show this, to not be showing this. Let's do first that. Let's remove it, chat. Let's remove the creative inventory. It's situated in the UI layer. It's situated in the UI layer. And let's search for the, when we press key E. Where is the key? Yeah, here. Here, show inventory. Yeah, let's disable it. Let's disable show inventory. Let's run it. Okay, now when we press the key on, now when we open the inventory, we don't see anything. We don't see anything. Okay, we remove the creative inventory. Let's just change it here. Where is the rendering, chat? Where is the rendering? Show inventory. No, it's not here. Show inventory menu. Yeah, here, creative inventory. Now we should be removing it. Now this should remove it, chat. Creative inventory. We'll replace it with a survival inventory. Okay, this is it, chat. This is it. We remove the creative inventory. We just have the this darker overlay. We have the darker overlay and we don't have anything. And we have the cursor showing and the player is not moving. That's perfect. Let's now render. Let's now render this. Let's render this. Render this. We need to find it. We need to find it. We need to find the graphic. Where could we find it? I need to go in the resource pack where I have all the defaults. Yo, Detective Jones, what did you do? You sent a gift membership. Thank you, man. I appreciate it. And who received it? Comported Box MPG. Nice. Detective Jones has probably sent maybe 10 memberships he has gifted. He has, yeah, double Detective Jones. I appreciate it. I appreciate it, man. Let me open the default resource pack, chat. Maybe a game mode, state, survival, and creative. Different menu depending on game mode. To add a game mode, we could, chat, that's a good idea. We could make it so when you press F3 and F4 to get this menu. To switch between creative, survival, and spectator. That's a good idea. Let's prioritize the survival mode. Once we have good enough survival mode, we'll make it possible to change between them. Yeah, that's the plan, guys. That's the plan. But let's first find this image. Let's first find this image. I had it. I had it in my D drive in backups. Yeah, here. We had it here in this resource pack. Okay, I found the chat. And so what now? We need to find the survival inventory texture, which should be in textures, GUI, container, and it should be here. Should be here. Yeah, this inventory. This should be it. This inventory one. This should be it. Yeah, it looks to be it. Looks to be it. We can open it. Can open it in Aspirite. Because I think we need to make some changes. But let's temporarily just move it here in textures. Temporarily move it here. Textures, GUI. Let's copy it here. Inventory. Okay, inventory. And let's open it in Aspirite because we need to make some changes. So we open Aspirite. We open the inventory. This is the inventory. I want it to be just the inventory. I don't want an empty space. I don't want empty space. Like this, chat. Like this. Okay, and we save it. That's it. And here you can notice we don't have Steve here because the game renders Steve dynamically and makes it follow the mouse. It's not a priority. It's not a priority. We could temporarily. This is what we can do, chat. This is what we can do. This is what we can do, chat. Desperate times calls for desperate measures. I need to scale this. Let's have it be in a new layer. Let's create a new layer. We'll just copy paste Steve. Which maybe will not be possible. It needs to be... let's create a new one. A new one. It will not be possible. It needs to be in a new file because it will pixelate it. Here, look at how this is like 300 by 300 almost, and this is 200 by 200 almost. It will pixelate it, so we can just open it here. We can open it here. Temporarily, we'll just use a PNG for Steve. It's all right just using a PNG because desperate times calls for desperate measures. Okay. We may even move it even more like this. We may even move it more like this. Okay. And we have Steve. We'll visualize him like this. And we'll call him inventory Steve. In the GUI folder, we'll call him inventory Steve PNG export. Like that. Yeah, okay. So here we have Steve for the inventory and we have the inventory. Let's now visualize the inventory, chat. So when the same way we created creative inventory, the same way we'll create the regular survival inventory. We'll call it survival inventory to differentiate between them. So let's first find the creative inventory because we'll copy it and make it be, we'll follow the same steps we followed for the creative inventory. We found it already here. It has one grid for the item slots and for the lower item slots. So basically I have two grids. Here I have this grid in the middle, and this grid down here. I have two grids to visualize items. For survival mode, it's also it's more than two grids. This is one of them. This is another one. Here we have one more, and here we have one more. So there are 4 grids here. We have 4 grids. Bro, that's the original. Bro saw the original and he's saying that's a nice clone. That's the original. We're currently developing it. Okay, this is the creative inventory. Let's copy it. Let's organize them a bit. Here we'll do... What was that sound? Oh, it's these guys. And send day. Let's make it be peaceful. Difficulty peaceful. Like that. Or I can still hear them. Okay, chat. Here, this part is for the don't spam. Yeah, 4 hours will be enough timeout. Okay, chat. Here this will be creative inventory. Will be creative inventory. And here this will be survival inventory. So be survival inventory. So here we have just a GUI, graphical user interface. We'll call it survival inventory. We'll call it survival inventory. And so in the UI layer, here, this is where we create the creative inventory. Above it, creative inventory, where should we create the survival inventory? Where should we create the survival inventory? Let's have it be here. Let's have it be here below where we create the menu shadow, which was the darkening on the sides. It's a little bit blur. It has blur effect. It makes it a bit darker. No, here it doesn't have a blur effect. It just makes it a bit darker. So that I call it the menu shadow. I call it the menu shadow. And so above the creative inventory and below the menu shadow, we'll create here, we'll have here survival inventory. Survival inventory. We need to prepare the texture. We need to prepare the texture. Need to prepare the texture. Here, let's load the texture. We'll call it survival inventory. Survival inventory. But the PNG is just called inventory. It's just called inventory. And so here, when we create the GUI, we'll give it a texture called, what's the texture? Here, it's called survival inventory. Survival inventory. Let's replace it here. Let's replace it here, like this. So we are targeting as a parent the whole screen. Offset is 0, 0. Scaling is a 4, and by default it should be centered. By default should be centered. And so here, instead of drawing the creative inventory, we'll be drawing the survival inventory. And that's it. So let's start the game and see. Bro, if I make a Patreon for people to buy this game, Mojang will destroy me. You will not... You're trying to put me in a trap. Okay, chat. Okay, I opened the inventory. And this is what we get, chat. So we are rendering the survival inventory. That's good. That's good. So what now, chat? What's the next step? Well, the next step will be to render Steve here. Not the 3D Steve. I want temporarily to have this Steve. I want this Steve, the PNG image. This inventory Steve. I just want that, chat. And then we'll move on to the what's more important. We'll move to the stuff that are priority. But let's temporarily try the PNG Steve. Let's try to add the PNG Steve. In order to add him, we need to go in the game layer. We need to load the texture. So here we'll call him. What's the name of Steve, chat? No, not this. What's the name? What did I call it? Inventory Steve. Inventory Steve. Inventory Steve. Here. Inventory Steve. Inventory Steve, like that. Okay, we have Inventory Steve. Let's actually load him up. In the UI, here we'll create a GUI. Inventory Steve, like that. Inventory Steve. And where should he be? Survival inventory. This is survival inventory. Here. We'll have him be here. Like this. Inventory Steve. Like that. So the parent this time will not be the entire screen. The parent will be the survival inventory. It will be the survival inventory. We want to position him properly. Let's open Aspirite. We want him to be positioned here at 26 and 8. At 26 and 8. And let's change the vertical alignment to be, vertical alignment will be the top, and horizontal alignment will be left. Will be the left. And let's see what we get as a result. Let's see what we get as a result. Oh no! It's too huge, man. Bro, what are we doing with this Steve, man? Bro. It needs to be way smaller. Yo, Frost, what's up, man? I haven't seen you. What's up, Frost? Usually in Twitch is like one person, so surprised to see people in Twitch. Let's not scale him. Let's change the scale of Steve to be 1. Let's change the scale of Steve to be 1. Let's see the result. Good enough. Good enough. Good enough. Here the offset, let's change it, multiplied by 4. Bro, I'll mute or even ban everybody saying I'm pre-recorded so that they're absolutely sure I'm not pre-recorded. They'll remember it for forever, chat. Okay, we have Steve. We have Steve. We have Steve, chat. Nice. But chat, it's a simple Steve. It's a simple Steve where he doesn't react. He just stares you infinitely. He stares you for forever. But it's good enough. This is the best we could do for a couple of minutes. I'm always watching on Twitch. I just don't talk much in the chat. Frost, it's maybe especially hard to talk in Twitch because it's nobody there. So it's understandable. Okay, we have a simple Steve. What's next? What should we do now? What should we do now? So we don't... When we destroy blocks... what should we do, chat? What should be priority? Should be a priority. Oh, here the items to be able to use them. These items to be item slots. These items to be item slots. That would be a priority. Block drops, that's also a good idea, chat. That is also a good idea, but it's not a priority because we can get the item without an item drop. We can just make it instantly come into the item slot. I think. We can do item drops in a separate stream. Let's organize everything. Let's make it a bit organized. So what would be the best idea right now? What would be the best idea? The best idea would be when we break a block to receive the block in the inventory. That would be the best idea. That would be the best idea. Here, chat, can you notice the X-ray vision down here? This is because the first time culling is not perfect. here the first I'm culling is working too strongly. I need to make it, it's removing too many subchunks. It's removing too many subchunks. That's for performance improvement. Okay, I'm thinking about it. Currently, I'm thinking about it. If I should do item drops or make it possible when I break a block to receive it in the inventory. That's what I'm thinking. That's what I'm thinking. What I'm thinking. Because the goal is to have the... What's the priority? After 3 hours, what's the priority? No, chat, I have a better idea. Maybe to have game modes right now. To have game modes, to switch between survival and creative. Maybe that would be more helpful, so I can organize it a bit better, the code. Because right now it's both creative and survival. But if I manage to switch between them, it will be easier to code. Okay, let's do game modes, and Mr. Arrow1234 approves it. So since Arrow1234 approves it, we're doing it. I was waiting for Arrow1234 to approve. Since he has given approval, we're doing it. What's the point of your comment, Mr. Rice? Add spectator? Yeah, it will be easy to add spectator. Like this, chat. We already have it. Done. We have spectator. It's very easy to add spectator. So it just changes if we have gravity or not. That's it. And it removes the UI. So spectator would be easy. Spectator would be easy. Let me think about it, chat. We got stuck. Okay, let's do game modes, chat. Let's do game modes. Let's have it be like this, chat. Let's have it be here like this, where you can switch between modes. Let's have it be like that. Should I make it like this? Should I make it like this? Should I make it like this? If I make it like this, if I make it like this, how do they render this, chat? How do they... it will take too much time. I'll do it without this visualization. It will just directly change it. It will just directly change between the modes. The useful part is having the different modes. That's the useful part, not the visualization. We don't have the luxury of implementing the visualization as well. Let's have it be, and we can display the current game mode in the debug screen. We can display it at the top left, what's the current game mode, just so we are absolutely sure what's the current game mode. We could try to do commands. Game mode, and here to pick between them. We can do, okay, let's do commands. Okay, let's do commands. And what will be the options? Creative and spectator and survival. Let's do that, chat. Instead, you need to make a game rule for each feature, and then changing game mode just changes game rules. So to make each feature have a flag, if it's like for survival or for like, so to add a flag for the gravity. Okay, Mr. Gravity, you are only for survival and creative. That's dumb. Today I lost my game source code, and that I feel bad for you. Ready, survival, spectator, then you can use 2 buttons. You can make that. No, we'll do the chat. We'll do chat. Game mode, and here we'll pick between them. We'll pick between them. Let's have as an option creative, spectator, survival. Let's do that. Because here we currently have, I could switch where my camera is because it will be in the way. Yeah, let's reorder stuff. Let me move myself. Maybe here. Maybe I should be here. Yeah, so guys, you can see here, hello world, like this. You guys can see. Okay, so here we have a single command, summon creeper. We have a single command. We'll add another command, game mode survival. This is what we're going to add. Do we need to switch quickly between them? No, that's not a problem. We don't need to quickly switch between them. Yeah, we only want the game modes, so it's easier to organize the code. That's why we want the game modes. Why we want them. Let me fix the summary. Yes. Okay, chat. To scroll through history, we have scrolling through history, but it gives only one of the previous commands. But it's fine. We don't need something like that. We don't need something like that currently. When you break a block, does it drop to collect or just go in inventory? We'll make it just go in inventory. When we pick as a feature item drops, that's when we'll do item drops. To change the block breaking sounds for other blocks, we could. Because currently we're using the stone sound when breaking foliage, when breaking everything. That's because we had very little time. And speaking of little time, let's lock in chat. Let's lock in. Okay, we have the survival inventory. The problem is we're in a weird gray zone where currently we have both creative, both spectator, and both survival mode at the same time. We have all of the modes lockout. We have all of the modes in the same time. I want to organize them a bit, to change them with commands. Here, game mode, survival. To change them with commands. That's what I want. That's what I want. So let's first commit this. How should we call the commit? How should we call it? Add survival inventory GUI, like that. Okay, nice. Create state to the player so player can change modes. Do you read chat from Twitch? I answered you. It was AFK. What did I miss? Alex, we have just the GUI of the survival inventory. GitHub desktop, yes. Okay. So where do we process the commands? We process them. Summon creeper here. This is where we process them. This is when we press the enter key. This is when we press the enter key. We already have F5 with the Steve model chat. We already have it. So here let's do if the player enters game mode. I could since we're since our commands are extremely simple, we can just do like this. Survival. We can just do like this. Survival. Here, let's do else if. Let's do else if. Else if. Else if. Like this. So survival, creative, and spectator. Spectator. So what should happen in all of these modes, chat? What should happen in all of these modes? So in spectator, we want draw UI to equal to false. And we want to not have gravity. F7. Here, player creative mode. Creative mode? Bro. No. It should be something else. It should be something else called. I think. When you... this is creative mode is the flag for how to disable block breaking in spectator mode. Okay, I have an idea, chat. Okay, we'll do it differently. Let's go in the player, and the player will have a state enum class. The state will be game mode. It will be game mode. And here it will be survival, creative, spectator. That's it. Spectator. And here we'll have game mode. Like that, chat. Like that. By default, let's have here const static game mode, initial game mode, a default game mode to be, I want it to be survival, since we're implementing the survival inventory. But sadly, can I do it? I want to initialize it here to be survival. Game mode survival. Like that. Okay, like that, chat. Okay, and so in the constructor here, we want, what do we want? Game mode to be equal to the default game mode, like that. Nice. That's it. And so in the chat system here, we'll get from the game layer player. Excuse me. Don't we have game layer? Yeah, we have game layer. Game layer player game mode equal. That's a bit of a bummer. You should let players select game mode on world creation. We could do that, but not right now. That's not a priority. There's already coordinates. Obviously, no adventure. I didn't see it, so I'll take your word for it. Stop hacking. Okay, chat. Why don't I have access to game layer? Here, this is game layer. Why don't I have access to it? Game layer, player, etc. Like this. Why don't I have access to it? Where were we? Here on the... Oh, no. Here? Yeah. Oh, it's on update. It's because it's here. So let's go on update here. Let's have game layer here. So here, game mode, let's have it be game mode. Let's have it be spectator. Here we probably need to do it like this. Player, game mode, spectator. So here creative and here survival. So let's do here survival. Let's do here creative. Like this, chat. Like this. Perfect. And what now? Now when we open the inventory, where is the inventory? Where is the inventory? Show inventory menu. Show inventory menu. Show inventory menu here. No. Here. Here. Here we'll do a switch of the game layer, game mode. We'll do a switch case if it's survival. So here we need to do player, game mode, survival. If it's survival, we open the survival inventory. And here, break. Was it like that? C++ switch. What was the syntax, chat? There were two versions. It's like this, chat. Okay. We open the survival inventory, else here, if it's creative, we open the creative inventory, like that. We open the creative inventory. And let me think about it. So on render here, on render here, if game layer player, now we need to do spectator mode. Player game mode equals, if it equals spectator, we return. We don't want to render everything if we are in spectator, but we need the chat. We need to interact with the chat system. Where is the chat? Show chat input. I want the chat input. I want the chat input. I want it. This part. So let's have it be here. Like this. Let's see the result, chat. Let's see the result. See the result. And we need to disable block breaking in spectator mode for sure. Need to disable. Okay, by default we're in survival mode. Perfect. And let's change it to creative. Now we're in creative. Yo, we're in creative mode. We're in creative mode. And here let's do survival like this. We're in survival, creative. We're in creative. We're in creative, and let's do spectator. And we're in spectator kind of. Brother. Not even close. Spectator needs some work. Spectator needs some work, chat. And we need to make it when we press space 2 times to start flying. To start flying like this. When we press space 2 times. That's pretty good, chat. That's pretty good. Okay. That's pretty good. Let me think about it. Let's copy this part. Let's copy this switch because we'll need it 2 times. On update, we need it. We need it on update. Where do we need it? I'll think about it. So what should be the next step? What should be the next step? Spectator is not perfectly fine. Spectator is not fine, but spectator, is spectator a priority? It's not. Spectator is not a priority. Spectator is not a priority. We'll focus because we don't have the luxury of having a lot of time. We don't have the luxury of time. It's good enough we have survival and creative, and we can switch between them. That's good enough. That's good enough, chat. So what now? What should we focus on now? Should we focus on now? And well, currently the goal is survival. Survival inventory is the goal. What should be the next step for survival? What are people expecting for survival inventory to actually work? People are expecting when we break a block to receive it in the survival inventory. And yeah, to have the hearts and the hunger. To have hearts and hunger, we could just display them. We could just display them. The hearts and hunger. We could just display them without having them work. Yeah, that's something we can do. And to display them only when we're in survival mode. Is it a priority? How much time do we have? We are 1 hour in. We are 1 hour in. We have 2 hours. We have 2 hours. Do we have the luxury? Should we add the hearts? Will the hearts and hunger help us in some way? Just the visuals? No, it just looks cool. Like the Steve here. But the Steve, I wanted him to be here because the empty space here was annoying. I just wanted something here. Steve was an exception. Yeah, let's make the inventory to be working. Okay, let's make inventory working. Let's make it possible to, when we break blocks, to receive them here and to drop them, which the dropping will just instantly delete them. So just delete them. Maybe to even have crafting working, a simple crafting here. Have simple crafting, maybe. Steve should follow cursor with head. Yeah, but Steve is a PNG. Steve is just a PNG right now. He's not a priority. Let's have the inventory working, chat. Have the inventory working. I got a crafting table. Chat, do you know how I got the crafting table? I got it from the creative inventory. That's how I got the crafting table. We need to change it so that we don't interact with the creative inventory. So let's copy this switch. Let's copy it. Let's go on update here. On update. It's when we press the left click. That's when the bug happens. Here, show inventory. Here, like this. This is for when we're in creative mode, we want to handle left clicking for the creative inventory. Else, we want to handle it for the survival inventory. That's it. That's it. So now when we left click in the menu, we shouldn't be interacting with the creative inventory. We shouldn't be interacting with it. Okay, I'm left clicking and we're not interacting with it. Oh, what's up, Okio? I haven't seen what's up. Okay, nice, nice. Okay, so what's next, chat? Next, we want here the item slots to work. We want the item slots to work because... Oh, I forgot to enable this chat. I forgot my light. Bro, it's... Why did I forgot my light? Here, look at how when I hover... Hey, chat, do you see this? I have Steve in my cursor. I have Steve in my cursor for some reason. I have Steve in my cursor. Maybe that's the last drawn item. Here, chat, if we hover over an item slot, if we hover over an item slot, nothing happens. But in Minecraft, if we hover, game mode, survival, here when we hover, look at how it highlights. Let's implement the item slots. Let's have the item slots working. Let's have them working. And then we'll make it possible to break blocks and receive item from the block. Let's do that, chat. Steve is infinitely staring down. Okay, chat, let's do it. How should we do it? How should we do it? Let's make a commit. Can switch between game modes. Okay, let me think about it. In the UI layer here, we want a grid. 2 grids we want. We want 2 grids here. They will be called survival inventory item slots and lower item slots. The lower one could be the same actually. Are they in the same position? Let's look at this. Can we reuse the creative inventory lower grid? Can we reuse it? So let's go from the bottom up. How much height is this? Let's start from here actually. How much height it is? It's around 636. It's this much. It's this much. Let's go in creative. Let's go in creative. In creative, how far off it is? How far off is it? It's not the same. It's not the same. It's not the same, but we can just change the offset. We can just change the offset. It's fine. We can just change the offset. But the parent is different. The parent will be different. Parent will be different. The thing I was trying out was to see if this part of the creative inventory is the same location as in the survival inventory. So I could reuse it. But it's a different location. It's a different location. So maybe I cannot reuse it. I need 1 minute, chat. What's up, chat? Okay, chat. Let's have the item slots, chat. Let's implement the item slots. How should we approach the item slots? How should we approach them? Let's implement them. And let's not worry about future problems. Let's focus on the next problem. What's the next problem? The next problem is to have the items to be able to hover them. That's the next problem. We'll copy the same thing we did for the creative inventory. For the creative inventory, we created this grid. Yo Q Doom, thank you for following on Twitch. Thank you. So we have two grids, chat. We have two grids. Let's copy them. And let's use them in the survival inventory. Let's organize the code. Survival inventory. Like this. And here, this is creative inventory. Like this. Okay, so here we want this grid. This will be called survival inventory item slots. Survival, and here this will be called survival inventory lower item slots. Let's have it be like that, and here as a parent we'll just use the survival inventory. And for a location, let's pick it manually. For location, we want this location, 884. 884. And for the other location, we want 8142. We want 8142, like that, chat, like that. So we have these two grids. We have the two grids. So let me think about it. What's next? Because if we play the game right now, everything will be the same. We need actual item slots, because these are just the grid which helps me lay out the item slots. But before that, let's change the amount of rows and columns we have. I think it's just 3 rows in survival. It's 3 rows only. It's only 3 rows. It would be cool if we add the functionality to have a backpack. Chat, are you here? We live, right, chat? Or did I pause my chat? We're live, chat, right? Yeah, stream is healthy. Okay, everything is fine. I got scared for a moment. Okay, chat. So what now? We want item slots. We have a grid to place the item slots. We have a grid to place them at the right spots. We have a grid. Let's actually use it. How should we use it? How should we use it, chat? We want these item slots. Bro. We want these item slots. And we have 2 versions. An item slot that's actually the state of the item slot. And we have a second version, which is the actual GUI. Should we... Oh, this is for the crafting table. I want to copy the creative inventory part. On the creative inventory. This is crafting table. All of this is crafting table. Creative inventory, main grid slots. This is the GUI. This is the item we hold in the mouse. So the cursor also can hold an item. We must not forget that. Cursor can also hold an item. But I already have a spot for it here, and this is just the visualization. It's only the visualization. This is for chat messages. This is for the hotbar. We don't need that. Oh, here they are, creative inventory item slots. These are the items, but yeah, these are just the state of the items. These are just the states. Let's copy them. Let's copy them. Let's use them. This is the creative. Let's do it in the survival. Survival inventory. Survival inventory items. Here we want the rows. The rows are 3. The columns are 9. That's it. That's it. What else? What else? Yeah, here. The first row. What other GUI do we have? This is the first row. Code bar item slots. Creative inventory first row. Let me think about the chat. Yeah, we want this item slot GUI. We want this item slot GUI. Yeah, this is what we want. This GUI. Slot. Yeah, let's copy this. Copy this. Yeah, here in the survival inventory, let's focus on the upper grid. Let's not focus on the lower grid. So in inventory, I have this grid. I have this grid. This is the upper grid. This is the lower one. For now, let's focus on the upper grid. Focus on the upper grid. We have set up the grid, the position, so that we can get the position for all of the individual item slots. We have that set up already. We have it set up. We want all of the item slots to have somewhere where they can store the state. I'm using this array here for that. For that, I'm using this array. This is for the main grid, for the upper grid. But we want the GUI as well here. We want the GUI. What is the GUI? We want the GUI, this thing. We want this thing. So here, survival inventory, we want it here, like this. And we'll call it survival inventory item slots. And here, 3 rows and 9 columns. 3 rows and 9 columns. That's it, chat. And so let's actually initialize them, chat. Let's initialize them. Initialize them. Let's see how we initialize the creative inventory items. And we'll just repeat the same stuff here. This is how we initialize them. We'll repeat the same here. We'll repeat the same. So 3 by 9, and here we do survival inventory items, and all of them will be just the invalid ID. So they will be empty slots. They will just be empty slots. They will just be empty slots. And what next? What next? Now we need to visualize them with this item slot GUI. We need to visualize them. Item slot GUI, we'll copy this. We'll copy this. This is the GUI. This is the GUI. We'll copy it here like this. So we go over 3 rows and 9 columns. We'll go over the 3 rows and 9 columns. Here we need to rename this to be survival inventory. The parent is survival inventory item slots. So the main grid, the upper grid, is the parent. The upper grid is the parent. So here we're creating all of the individual GUI item slots. Horizontal alignment is left, top. They are read only. Read only is for the creative inventory. We'll make them not be read only. For survival, we'll be able to change them. We'll set the ID here to be the survival inventory items. The survival inventory items, will connect them with these ones because they're shared pointers. We can easily connect them. When we generate model, we generate textures. Let's test now. Let's do a test and see what the issue is. Move the camera to the left. Why do I need to move it to the left? What's in the way? What's in the way, Mr. Artem? Okay, chat. This is it. This is it. We have the item slots. Only on the upper grid. We have the item slots from the upper grid. Nice, nice. Perfect. So what now? My eyes in pain. I can move to the left. I can move to the left. It was to the left initially. We moved it to the right so we could see the chat, but there isn't much chat right now. I can move to the left. It's not a problem. Okay, so we have the item slots. What's next, chat? What should we do now? What should we do now? We don't have item slots for down here. We don't have. And also, if we go in creative, and if we fill up some item slots, look at how here the hotbar item slots synchronize with the creative inventory item slots. And if we go in survival, that's not the case. In survival, that's not the case. Let's change that. Let's synchronize here the hotbar with the survival inventory. Let's synchronize them. Let's synchronize them. Okay, chat. Let's focus here. So, let's synchronize them, because here, look at how the hotbar is synchronized with this part. Let's do that, chat. Let's do that right now. Let's do that. How should we do it? In the UI layer. In the UI layer here, we want... how should we do it, chat? How should we do it? Let me think about it, actually. Survival inventory, items. So yeah, we focused on the upper items. Let's focus on the lower items. Focus on the lower items. And how should we do that? We want just item slot GUI. We want just item slot GUI. That's what we want. Here. And we'll call this B survival inventory first row. That's how we are going to call it. How we are going to call it. And what next? What should be next? Let's copy the same thing we do here. Copy the same thing. So in UI layer here, let's copy this, chat. Let's copy this and let's do the same thing here. Let's do the same thing here. Do the same thing here. We'll call this survival inventory first row. The parent will be survival inventory lower item source. Do we have something like that? Yeah, we have something like that. We have something like that. Here hotbar items. That should be it. Positioning. No, positioning should be all right. Okay, we should have all of the item slots in the survival inventory working. Let's see if they're working. If they're working, we'll think of what should be the next step. Here was the issue. What's the issue here? What's the issue here? Because we are searching for hotbar items, which they are not yet initialized. Hotbar items. Let's initialize them here. Let's initialize them here. like this. Initialize them. Let's see. Okay, it's compiling, it's running, no crashes. And here, all of the item slots are working, at least the ones that are priority right now. The ones above, I haven't focused on them. Current focus is these two grids, and they're currently working. And if we switch to creative, and get some items, and if we switch back to survival, and look at this chat, we have items. That's cool. Nice. Oh, and they're synchronized. They're synchronized between the survival. This lower part is synchronized with the survival inventory, with the hotbar inventory, and the creative menu inventory. All of them are synchronized. So what's next, chat? What's next? What should be next, chat? Bro, we're doing survival inventory. What's next in terms of survival inventory? We're not done, chat. What do you mean? Biomes. What's next, chat? Offhand? No. Currently, let me think about it. Hearts and hunger, health. Let me think about it, chat. Should we leave it as this and focus on another feature? How much time did we invest? An hour and a half. Okay, it's all right. It's kind of all right, chat. It's kind of all right. Should we do crafting? No. Crafting is a separate feature. Crafting is a separate feature. What should be next? What should we do now? Should we do item drops? Should we do generating an item in the right hand? Should we do item drops? I think item or health and hunger. Health and hunger, it's best to have them be when we have mobs. To have Steve look at the cursor, that's not a priority. When we have this Steve animated, that's when we're going to do a chat. When we have this Steve animated. That's the best time to do it. That's when we're going to do it. Make item in right hand. No, let's do... what's up, oh creeper? Sub creeper? Let's do this chat. Animate right hand, block world would be good things. Make the grass doesn't float if you break block below. Animation Steve. Animationless Steve jump scare. Boo. Okay, chat. Amount of items in item slots. Maybe like block updates, like how when you break the block. Let's do item drops, chat. Let's do item drops because if we do item drops, we'll be able to pick them up and we'll be able here to have an item count and we'll be able to throw items. And after we have item drops, we'll visualize items in the right hand. We'll visualize them in the right hand after we have item drops. Hunger and health would be best when we have creeper. When we have the creeper working, that's the best time to implement the hearts and hunger. That's the best time to implement them. Yeah, let's do item drops, chat. And item drops will be very simple. They will be very simple. You will be banned. Not even a mute. Okay, chat. me think about it. Let me think about, or should we do a poll? I think maybe a poll to do, chat. Maybe to do a poll. I think maybe to do a poll. Start a poll. What to do today? Make creeper move. Item drops. Show item in hand. Animate Steve. Third person Steve. Let's pick what we're going to do, chat. Let's pick what we're going to do. Chat, decide. Decide what we're going to do today. So we have a few options today. We have a few options. If we make the creeper move, we'll be able to... Where's the creeper? For the creeper, we need pathfinding and the A-star algorithm, which will be a bit of annoying. It will be annoying. But if we manage to make him follow the player and explode, it will be cool when we have the item hearts. If we do item drops, it will be cool because survival inventory will be able to finish the survival inventory if we have item drops. Because currently all of the items are infinite, we don't have item count, we cannot drop items, we cannot collect items. That's a bit of a bummer. Show item in hand, it will just look cool. It will just look cool. And animate third person Steve. If we manage to animate in third person Steve, that would be cool because we'll have him animated in the inventory as well. We'll have him animated here in the inventory as well. Chat, so what are we doing? Okay, let's end the poll. What did chat decide? Chat decided to make the creeper move. Bro. Why did you decide to make the creeper move? Bro. Do you recommend IMGY plus Raylip? I don't like IMGY in Raylip because here when we implemented the structure block, we used it as a UI here. We use it as a UI here, and it's a bit annoying because when we move the cursor, when the cursor lands in the IMGUI window, it breaks the game. It happens sometimes, chat. It happens sometimes. Not right now. I don't know why it doesn't happen right now, but sometimes it happens. When you move cursor, etc. Sometimes it happens. Yeah, like this, chat. Look at this. It broke the UI. This sometimes happens. Like I hovered this UI temporarily and it showed the cursor. I haven't implemented this, chat. This is only through IMGUI. So it's a bit annoying having both IMGUI and Raylip. That's a bit annoying. Okay, so chat voted. So the first vote chat did was for survival inventory, and we implemented the survival inventory where we just render the PNG image. We have here working item slots. We have working item slots, and we have this static Steve. That's about it. That's about it. But we don't have block breaking, so we cannot increment and change here the item count. And we also implemented here to change between creative and survival mode. Here we can change between them, between creative and survival, which just changes the inventory. And by default, when we start the game, we're in survival mode by default. Okay, chat, so this is the creeper. Chat voted to add pathfinding to the creeper. That's what chat voted. What's weighted A sharp? What's that, chat? I know A sharp is a pathfinding algorithm, but what's weighted A star? A sharp. Weighted A star. Here, weighted. Here, I remember there was an illustration. This is the A star algorithm. We start from here, this red dot, and the goal is this green dot. And this is the A star algorithm. This is the default implementation, which is probably too slow. Probably it's too slow. And here it manages to find it. That's it. But there was another version that was a lot faster. This A star search that uses a heuristic that is 5 times obtain suboptimal path. It's maybe not this. Maybe it's not that. I started trying to recreate Minecraft Roblox. Good luck. We're doing pathfinding. Yeah, we're doing pathfinding. We'll just use the regular A star algorithm. We'll use this A star algorithm, which just you give it a starting point and ending point, and it manages to find a path. The starting point will be the creeper position. The ending point will be the player position. And the A star algorithm will find a path for the creeper to follow to reach the player. And once it's close to the player, we'll make the creeper start exploding. That's the goal here, chat. That's the goal. We already made an attempt for this. We already made an attempt for this. We made an attempt for this. And in the last attempt, the thing we did is we implemented the creeper, which has collision with the world. Creeper has collision with the world, and we can spawn it here. Summon creeper. We can summon it with the command if I type it correctly. We can summon it with command. And also we started work on the A star algorithm. We started work on the algorithm, and I made it so. I just commented out. We started writing it. We didn't have enough time to finish it. And I started writing the algorithm in the player class. Yeah, here. And we commented out. And I just called it a function called test. That's what I did. We can comment it out. We can comment it out like this. This is the A star algorithm, chat. But we didn't fully implement it. We were close, but didn't fully implement it. So what now, chat? What should we do? Will this code compile? Let's first see if the code compiles. No, it doesn't compile. Let's see. Let's try to make it compile, because this code that is the A star algorithm, and it's pretty good. It's pretty good. It's not finished, but it's pretty close to being finished. We need to see. Oh, let me think about it, chat. Should we delete the first attempt and make a new attempt, or should we continue this attempt? I think it would be best to temporarily comment it out, and just so it manages to compile, just so it compiles like this. Let's comment it out and run it. Will it run? It runs. Okay, chat. Okay. So let's implement the A star algorithm. This is a pathfinding algorithm. The creeper will use it. But just to make it simpler, we'll make it so, we'll keep it very simple so that we can actually progress, chat. We'll make it very simple. Instead of starting the pathfinding from the creeper, we'll start the pathfinding from the player. And we'll do it when we place a torch, or like when we place something. Like when we place this redstone torch, yeah, like this, chat, like this. We'll place a torch and we'll run an A-star algorithm, pathfinding algorithm from the player to the torch. And we'll visualize it, the path. We'll visualize the path just to see what's the result. What result we get. The moment we start getting a pretty good path, we'll move it to the creeper. That's the idea, chat. That's the idea. That's the idea, chat. So the algorithm itself is written here in pseudocode. Pseudocode is not a particular programming language. It's just an informal language where programmers write algorithms. Because some programmers know JavaScript, other programmers know C++, and because this needs to be in a general way formatted, that's why people use pseudocode. You cannot compile this language. You cannot compile it. So we need to translate this to C++. We need to translate it to C++, chat. That's what we attempted last time, but the attempt was so bad that it couldn't even compile. That's the current situation. It couldn't even compile. So that's why we'll start in a more simple way. Here we have a test function where we'll give the function a destination. The starting point will be the player position. That's what we're going to do. Starting point will be the player position. This time, I will not do the same mistake as last time. And what's the mistake? The mistake is where I wrote a lot of code and ran it at the end. And this way, I didn't know where the problem is. Because everybody knows that C++ has extremely bad compilation errors. C++ cannot tell you where's the problem. So this time, we'll write a little bit of code and we'll compile and run it, just so we can progress a lot faster. That's what we're going to attempt today, chat. So let's try to reproduce the algorithm in C++. We could just translate it from here, or we could just search at C++ A* implementation. Just for a reference. Just for reference. We could do that as well. So here we found the GitHub repository of the algorithm. Here it has some kind of a generator. You set a world size. We don't need a world size. We could just think of it as a limitation of how much the creeper can look in the world. So we can limit the creeper view distance to be like 30 blocks by 30 blocks by 30 blocks. Like this will be the world of the creeper. And this here is two-dimensional because the world size has two arguments. We'll see if that's a problem. Here set heuristic. Here they probably give it some kind of a function. The function we'll give it, we'll decide on it a bit later. Not right now. We'll decide for the function a bit later. And here we do, what do? They do find a path, and this is probably the start and the end. And they save the path in this variable, and they go over all of the coordinates and put them on the screen. And this is their A* pathfinding. Let's quickly, temporarily, let's look at the code just to see their implementation. Let's look at the header. In their header, they have a vector implementation, which just has an X and Y. What else do they have? uint is just an unsigned integer. We don't care about that. The heuristic function was this. This is just a function that takes in two vectors and gives a result, an unsigned integer. Coordinate list is just a vector of vector 2's. And they have a node. Each node has some kind of information and it has a parent. Should we do a parenting system, chat, for implementing this? Or maybe they have the parents so that they can reproduce the entire path. So they probably do it for reproducing the end result of the path. Probably, I assume. What else? And here they have this generator class. What does it have? Find node on list. Generate set world size. This is probably just to set up everything. Just so you can set it up. We don't need this class. We probably don't need it. Okay, let's go inside of the CPP file and let's see how they implement it. Let's see how they implement it. Yeah, find path. This is where they start. And they have a current node. They have a node set. The annoying part here is that this person renames his types. So we don't know what node set is. We need to search it and see what it actually is, which is extremely annoying. Because nobody in this world knows what node set is. Only this developer knows what node set is. That's why it's annoying. Node set here. So it's a vector of references to nodes, of pointers to nodes. So it's a vector. So this is a vector. It's just a vector. And here we have an open set. Isn't parenting needed for backtracking? We'll see. So they have here open set and close set, and they reserve 100, a size of 100 for these two vectors. For the open set, they just push a pointer to the starting position, to the start position, when we call this find path function. And what do we do here? We iterate over the open set until it has elements in it. We have here the current position. This is the starting point. This is the starting point. And what do we do here? We go over all of the elements in this vector, the open set. We go over all of the elements. I don't like this implementation. Because here he goes over all of the elements. I'm not a fan of that. We could probably do it a bit better. Or we could probably find a better solution. Yeah, here, look at this backtrace. I have this backtrace here. And here they take in references, a star, adjacency list. Here they do it with an adjacency list. Missing and redundant const. These titles looks as if they are like AI. Unnecessary use of share pointer. I use share pointer. Is rather heavyweight pointer. I use that. Let's see another implementation, because I don't like this one that uses adjacency list. If we don't manage to find a cool implementation, we'll just do our own using the pseudocode, and we'll keep it simple. Okay, let's just use the pseudocode. Let's just use it, chat. So we have a start, and we have a goal, and we have the function here, heuristic function. Okay, and we have here open set. Sure. Look at how here open set is the same name they use here, open set. Maybe this person has also gone through this pseudocode. Probably. Okay. Okay. I'll move this to the side and we'll just start implementing it. Any kind of a solution. Let me think about it, chat. Okay, chat, here. So for sure, whatever the implementation it is, we'll need a while loop. Here we need a while loop, and here we need something called an open set. We need here an open set. What should be the type of this open set, chat? What should be the type of this? And we need here a node. Here we need some kind of a structure node. We need some kind of a node here, chat. We need node. Whatever the type of the open set is, it needs to take in nodes. And here it needs to be while open set empty. While it's not empty, here we need to get the current node. Open set pop or like top, like something like that. And open set pop. And here we will need to go over current node neighbors, like that, chat. This is roughly what we need to do, but we need specifics. What would be the type of the open set? What should be the type, chat? So you guys are suggesting open set to be vector of nodes. Let's see what the use case would be, chat. Let's see what it requires, chat. Let's copy this open set name. Let's copy it here like this. Let's zoom in so it's easier to see. So at the start, this is the set of nodes that are discovered. These are the set of discovered nodes that we may need to go back to them. Initially, only the start node is known. This is usually implemented as a min heap or priority queue rather than a hash set. Oh, okay. So they just tell it to us, chat. They just tell it. We need either a min heap or a priority queue. So let's search min heap C++ and let's see what we get as a result. And let's search priority queue C++. Priority queue and min heap. What do we get as a result? So basically both cases have at the top, they order the elements so that when we get an element, we get the minimum value or the maximum value depending on how you configure it. So here look at how they have a bunch of numbers, and look at how at the top we have the number 2, the lowest number, and they are not perfectly ordered. They are not perfectly ordered because it will be too costly to have them like perfectly ordered. You can implement min heap as an array data structure. Sure. Oh, here they just implemented by themselves. They implemented by themselves. So, oh yeah, well, let's change the name, chat. Let's change the name because a lot of people may be clicking the stream expecting survival inventory. Mob pathfinding. Mob pathfinding. Okay, chat. I updated. Thank you. Thank you. I updated the title. Doesn't 3 make the largest number in science? I don't get what you mean. Okay, so here we have two options for the data structure. One option is min heap, the other is a priority queue. We searched for min heap for a particular implementation and we couldn't find one. Here they just use a vector for it. They just use a vector. They just use a vector. Returns the topmost element. Look at how returning the topmost element is time complexity of 0.1. It's a constant, it's instant. Returning the topmost element. Inserting a node is log of n. Inserting a node is log of n, which is faster than just O of n, I think, probably. Is it faster? I forgot. Should be. The way to check this, we can go to Desmos here and we can just do a graph chat. This is how you can check which algorithm is faster. Here, let's just do x and log of x, log of x. And here, let's compare it with x to times of 2. Times of 2. And look at, okay, so n is slower than log of n. N is slower, chat. Because what's n? What's n, chat? This is for like time complexity. You don't need to worry about this, chat. But I'll just mention it. N is just the number of like the more like it's like the array, the number of elements. It's like n, you can think of it the scaling the algorithm. The more elements you run the algorithm on, the more n scales. You can think of it like that. And so here on the x, let's say that's n, and on the y, it's how much, like, let's say, time it will take, let's say. And so look at how here, how n of 2 is like, look at how fast it goes up. This means the algorithm would be very slow. And n would be faster, but log of n would be even faster. Log of n would be a lot faster. And the fastest would be just a constant. Fastest would be a constant. So what this means is that for this data structure, the min heap, getting the element, the top element, is the fastest. Inserting an element is a bit slower, and the slowest would be building a heap. Building a heap from a given array. We give it an array and it builds a heap from it, which we will not be using. We will not be using. Let's look at the priority queue. Let's look at the priority queue. Okay, chat, this is very good. We have a C++ implementation of a priority queue. We don't need to implement it ourselves. That's good, chat. That's good. Do they have time complexities here? No, they don't. It's not that big of an issue. That they don't. Once I started talking about time complexities, min heaps, and priority queues, everybody left. That was funny. Okay, let's use the priority queue. Let's use the priority queue. I'll not be lecturing you guys. Let's use the priority queue. Okay, chat. Here we'll use priority queue, like this, chat. We'll use a priority queue. Let's implement it. Let's implement this. Okay, priority queue. We already have it. We already have it. Let's comment this out temporarily. Let's comment it out. Let's run it as it is, like now, just to see if it compiles. Okay, it compiles. Perfect. Nice. It compiles. Sure. What should the node be, chat? Okay, we have a priority queue. That's nice. That's nice that we have a priority queue. Did we have nodes before this? I don't think we had. I don't think we had. Okay, let's go back to the pseudocode of the A star. Where is it? Here, chat. Okay, we have an open set, chat. We have an open set, and we have a start, we have a goal. We have a start and we have a goal. Let me think about it, chat. Because we have one slight issue, chat. We have one slight issue. The issue we have is the priority queue needs, it sorts the elements. The priority queue sorts the elements automatically. And it sorts them based on the values inside of the node itself. The issue is here in this pseudocode, they have the values, the G score and the F score separately. They have them separated from the nodes. And so the priority queue will not be able to sort them if the information is outside of the data structure. That's a bit of an issue. That's a bit of an issue. OpenSet is having, okay, so here we get the node from, okay, this is the way we're sorting them. We're sorting the elements by having the lowest F-score value. By having the lowest F-score value. This operation can occur in log n of time if OpenSet is a min heap or a priority queue. Okay, sure. Okay. We could have the F-score be separated here and in the node itself. We could copy the F-score in the node itself so that priority queue can order them around. The issue with that is if we change the F-score of a particular node, it will break the data structure. It will break the state because the data structure will need to reorder them automatically. That's a problem, chat. We could every time just destroy the data structure and create it again. Like this build heap function here, build heap, to give it all of the F scores and to build the heap again. And this will be of complexity of n, which is slower. It's slower than log of n. So we need something else. We need something that's not that slow. Let me think about it. Okay, let's continue. We have the current node. We have the current node. Sure. And if it's the goal, if the current node is the goal, we just end it and reconstruct the path. We don't care about this right now. We don't care about this. So here we go over the neighbors of the current node. We need to go over I don't think that code changes it afterwards. Just insert and remove is needed. Oh, we are not changing it afterwards. Okay, so then we can copy it. Okay, that's nice. Thank you, Gaming Studio. Well, if that's the case, then it shouldn't be that hard. It shouldn't be that hard if that's the case. Okay, we need to go over all of the neighbors. We can easily get the neighbors of a block, of a position, by just taking its current position and calculating the north, east, south, top and bottom neighbors. That's how we can get all of the neighbors. But we will need not only in front, behind, to the left and right. We need here as well. We need here as well, maybe. Because here, the creeper, let's say, is trying to reach here. Let's say the creeper is trying to reach there. And the path is saying we go here and we reach this block. And how are we going to reach there? The creeper needs to jump. He needs to jump. He will see this block is taken. If this block is taken, we'll look above it. If above it is empty, we'll do a jump. We'll do a jump. Yeah, summary is a bit broken, but what can we do? Let's focus, chat. Let's focus on what actually matters. Let's not try to overly complicate. Okay, chat. Let's make it simple. Let's not worry about going up and down. No, chat. Let's keep it simple. Let's keep it simple. Let's have it be very simple, where it will just follow in a flat terrain here, like this, chat. We'll give it like this. We'll give it a target like this. We may even build some kind of a maze. And this is enough, chat. We'll have it be on a one axis. Once we make this work, we'll add jumping up and down for the pathfinding. Let's keep it simple, chat, because I want to have some kind of implementation. So here for the neighbors, we'll just look at the north, south, east, and west neighbors. If priority does change, though, I guess could just remove it and then add it again. Yeah, we can do that. We can do that. Okay, we can. Yeah, that's a good idea, chat. And again, of course, it's from gaming. Gaming calls always gives good ideas. Okay, chat, we go over all of the neighbors. We calculate some kind of a value here. Okay, let's do it, chat. Let's do it. I have an idea. Let's do it, chat. I have an idea. Let's do it. Yeah, okay, chat. Okay, node. Okay, for the node, we want the priority queue needs to sort them based on an F score. Is it a float? Let's say it's a float. F score. And here we need a position. Should we do simple position, which is just the global position, or should we do position details? Position details has more data to it. It has local position, subchunk origin, and block origin. It has three vectors inside of it. I'm not sure which one should I pick. If I pick just the global position, we will save up on space. 3 times less space. If we pick position details, it will make it easy to find the neighbors. Because every time we will need to convert this to a position details. We will need, so that's the difference. Less performance versus less, okay, let's use position details. Yeah, less performance versus less memory. Let's save up on performance, chat. We can use the memory. Let's not care about memory. So looking at this, for the G score and F score, they use, what do they use for this? A map. They use a map. We can use a hash map for this, where we can just use the block origin, chat. Here. Okay, let's compile this just to be sure it works, just to be sure it compiles. Then we'll do the open and close. Okay, let's do the open and close set. So here let's do unordered map of, what should it be? A vector 3. This is the global position, and it points to a float. And this will be G score. And we need another one. This will be F score. But since this hash map doesn't know about this vector 3, we need to give it a custom hash function. The hash function just converts this vector 3 object into like an integer, I think, in a hash, which makes it easier to find them a lot faster. So here we just need to give it as a third argument, vector 3 hash. I think that's what it was called. Was it vector 3 hash? Was it vector 3 hash? Was it? Where do I need to find it, chat? Where did I? Yeah, here. Here. Oh, it's inside of the block. It's inside of the block class. So here I need to do block vector3 hash like this. This will make it work. If I don't have this, it will crash. That's why I added. Which basically is just a structure that has this function which just returns an integer. Size t is, I think, probably an integer of 8 bytes. And here I calculate the integer myself. I calculated myself where I just use XOR and shifting. I use XOR and shifting. Here, this is the x coordinate, and then I XOR it with the y coordinate, shift it 1 time, and then with the z coordinate, shift it 2 times, which is a bit of a problem because I limit my subchunk positions to be of 1 byte, I think, of 1 byte, something like that. I will need to improve it in the future. I will need to improve it sometime in the future. Make sure to multiply h estimate by 1.5. You can game playtest right now. Let me first find it. Where was the code? Here. Okay, let's run it to see if it's fine. Okay, it's still fine. Okay, nice. This is a good sign. Okay, what now? Chat? Now we want what should we do, chat? We want this priority queue to be custom. We want custom comparator between them, chat. Custom comparator. Let's look how to do it. We could do the same thing we attempted before, like this. We could do the same thing here. So basically we had to do a structure. Like this. Like this. And here we will return, what should we return? This is just a position detail. This needs to be node. Because here currently the priority queue doesn't know how to work with this node. What the priority queue does, it automatically sorts them, so when we get the next node, it's sorted by probably the lowest F-score. We need to actually use the F-score. So here we want a custom compare operator. So here, this is the left and the right node. So here, this will be a node. This will be a node. And here we compare them. We compare them. Left, F-score, higher than right, F-score. Like that, chat. Like that. So we need to give it here. Position details, vector, custom operator. Can we just give it like this? Custom compare operator. Does it run? If not, then we need to give it a second one. std vector of node. Let's run it again. Okay, it runs. Nice. That's good, chat. That's good. So what next? What's next? Let's look at the pseudo algorithm. So this is what we do, chat. We need to give the starting position into the open set. Let's add it to the open set. F score and G score. G score for the start will be 0. Okay, let's first do the scores, chat. G score, and let's rename it, chat. Rename it like this. So G score of the starting point. Where is the starting point? Let's do here node start. The start. How should we do it? The start needs to be F score value. Let me think about it. No, we just need a vector 3, chat. We just need a vector 3. We'll create the start after all of these. After all of these. Let me think about it. Okay, G score. We need the starting point, chat. Starting point is a vector 3. Start point equals. Starting point is the player position. Player position. Just position. It's just the position. It's the current position. So G score of the current position equals 0. Equals 0. Let's have it be. Let's do it like this, chat. Position details. And here position. Like this, chat. So we get the actual block origin, chat. So here we'll do start point block origin. This will be 0, the G score. I'm just following the pseudocode. And the F score will be the F score of the start position will be, what should it be, chat? In the pseudocode, what do? They do F score here. What do? They do the heuristic. Which should be maybe just the distance. Maybe it should be just a rough distance between the start and the destination. Something like that, chat. So let's see what heuristic we would use. Yeah, this, chat. This is what we're going to use. We'll just reuse our previous code. The destination. Let's have a destination position detail. Do I have it here? I have it as a vector 3, the destination. I can have it as a position detail. This is the destination. And let's rename it here as well. Like that. Rename it here as well. Nice. So here is the destination like this, and this is the current node. This is our heuristic. Destination. This is our heuristic, which just calculates the distance between the destination and the position we give it. That's it, chat. So here the F score will be just our heuristic of the start point. Like that, chat. So here we can finally create the starting node. We can create the start node. Here F score will be our current F score. Start point block origin. Like that. And a position. For a position, what should we give it? It's just the start point, chat. It's just the start point. That's it. And so we need to push it. Open set. We need to emplace, push. What do we need to use, chat, for a priority queue? Let's see how do everybody use priority queue. It could be cool if you add an option where you can make your own village and buildings. What do you mean? So what do we need to do now? Now we need to check priority queue C++ usage. I want to see the usage of the priority. Oh, push. So we just need to push. Okay, we just push. Here, let's do push. We push the starting node. Like that, chat. Like that. And let's see if everything runs. If everything runs, that's a good sign. Everything runs. What's the issue? The cool part is, since we run it many times, the code, we can do a guess on where the problem is actually. Because we know most of the parts are actually working. Just few parts we added right now. We added just a few parts. Missing type specifier here. Oh, we haven't imported here. Position details, right? That's the issue. Position details, we need to include it here. That's what the issue was. Let's run it again. Let me get up, because I was sitting for a long time, chat. Okay, it compiles. It compiles. Compiles, chat. Compiles. That's a good sign. Oh, bro, this algorithm is so much coding. But we need to finish it, chat. I want to finish it. We don't have much time. We have about 30 minutes, let's say. We have 32 minutes left. But we're pretty close to actually having some kind of implementation. We're pretty close. Okay, we have a priority queue. We have G scores and F scores. And we have nodes. And we can order them, etc. We have heuristic. We have everything we need, chat. We have everything we need. Let's do the main loop of the A star. Let's do the main loop here. Let's do the main loop where we just go over the current open set, which is this priority queue. We go over it. And here we get the top element. But let me see how they use the priority queue. How do they use it? Yeah, they get the top and they pop it. Just what I did. Exact same thing, chat. Okay. So we go over the nodes. We get the top node, which should be with the smallest F score, probably. It will be probably with the smallest F score. Make sure to multiply the heuristic estimate by 1.5. I'll take note of that. Make sure to multiply with 1.5f. At some point we'll test this. Maybe it's for performance. So we get the current node. Sure, we get the current node. We need to go over the neighbors. And also we need to check here if current node position, if it equals to the destination. If it equals to the destination. Done. And here. We need to end it here. we end it here. Else we need to go over the neighbors. We need to go over the neighbors, chat. We need to go over the neighbors. Where is chat? Is chat? I'm back to the stream also. Are you using K-star? Yes. Let's open here the algorithm. Yeah, we go over all of the neighbors. Sure. We go over the neighbors and we need to calculate this tentative G-score. We need to calculate this, chat. We need to calculate it. Okay, let's calculate it. Let's calculate it. We need to go over the neighbors first. How should we go over the neighbors? We will focus just on 4 neighbors. North, south, east, and west. 4 neighbors. How are we going to iterate over them, chat? How are we going to iterate over them? We could implement an iterator, maybe. An iterator. How should we iterate over them? Because currently we have the... Let me think about it, chat. Because we can easily get the 4 neighbors, like this, chat. We can get them position details. We can get the north neighbor equals... We'll get it from the current node position get north, like this. And we need to do it 4 times. South, east, and west. And west. That's it, chat. We done. We went through the neighbors of the current node. That's easy. That's easy. We need to run the same function for all of the for all of them. We need to run the same function. Let's create it as a lambda. Let's create it as a lambda. Here we'll just call it to be neighbor. Just a neighbor. Like this. We'll just call it a neighbor. For each one of them, we'll run the same function. We are not doing diagonal as of now. We want to keep it simple, chat. We want to keep it simple. Let me think about it. Here. Auto. Neighbor. How should we call it? How should we call the function? How should we call it? This is a function we run in the A star for every neighbor of the current node. Go to neighbor. Let's call it go to neighbor. I don't know. Go to neighbor. Here, this will be a lambda. This will be a lambda. This will be a lambda, which is just a function. It's just a function, chat. Nothing complicated. Nothing complicated. Just a function. And what now? Here we need to, and here we need as an argument here the neighbor here. We need const position details reference neighbor. We need the neighbor here, and we'll run it here. Go to neighbor. Neighbor. We'll run this code for all of the neighbors. We'll run it for all of the neighbors. And what should be the code? Well, following the pseudocode, here we need a float tentative G-score. Tentative G-score, which will be what? What will be the tentative G-score? Well, they do, here we need reference to G-score. They do G-score They do G score of the current block. We need the current, so here we'll give it. Here we'll give it const node reference current node. We'll give it current node. Here current node position. We get the current node position. What's the issue here, chat? Oh, block origin. Block origin. We start, brother. Okay, we get the current node G score plus the current and neighbor weight of the edge from the current to the neighbor. Distance from, oh, here, look at this, chat. They add to the G score, the current G score, they add the weight of the node. So they're just two nodes. The line that combines them, it has a number, which we can take it as the distance, the actual distance between them. So between these two, they are direct neighbors. So for me, this will be one block, chat. For me, this is a one block. Let's do here one, like this, chat. Let's do one. Let's do one. And what now, chat? What now? So here we need to do if tentative G score is less than the G score of the neighbor. Neighbor block origin. Neighbor block origin. If it's less than this, we need to do some code. Else we don't do anything. Else we don't do anything. So what do we do, chat? What should we do for every neighbor, chat? What should we do? So we need here to update the G score and the F score. And we need to do this, whatever this is. Oh, this is for having the path, chat. This is when we reconstruct the path. This is when we're reconstructing the path. Okay, okay. And here we update the G score and the F score of the neighbor. Sure. Sure. And if the neighbor is not in the open set, we add it. And we add it. But chat, if it is in the open set is a priority queue. If it's in the open set, we need to remove it and add it again so that we can update his current F score, chat. We can update his current F score. Let's do it, chat. Let's do it. So we need to do this. We need to do these steps, chat. To update the G score, the F score. If the neighbor is not in the open set, to add it. If it's in the open set, we remove him and add him again. That's it, chat. And maybe to implement this came from, but not right now. We can skip this. This is for when we actually reach the goal. But currently I don't care about this. I don't care about this. Okay, so here, if the tentative G score is less than the neighbor G score, we update it. We update it, so here G score, neighbor, block origin, we set it to be the tentative G score. And here F score of the neighbor block origin equals the tentative G score plus the heuristic of the current of the neighbor position of the neighbor, the heuristic of the neighbor. Here we need tentative G score. It's a float, right? F-score. What's the issue, chat? What's the issue? Heuristic. Closing function. Oh, I'm using a lambda inside of a lambda. Oh, so it needs access to it. Heuristic. And it needs access to F-score. Needs access to them. And now we want here. What should we do, chat? Here, let's do auto iterator equals open set find. We want the open set as well. We want open set. We want the open set. We want to look for. Do we have a find function? What functions do we have? I want an iterator, chat. I want an iterator. Priority queue iterator C++. I want to iterate over them, chat. I want to iterate over them. Doesn't allow iteration through all the neighbors. That's a bummer. Okay, can we search for, can we check if a neighbor is in a priority queue? Or we cannot do that. Priority queue check contains C++. Priority queue. Does it have contain? Inserting an element. Here we just push it. Accessing an element. We just get the top. Deleting an element. We just delete the top element. Oh, and if it's empty. And the size. And pseudo traversal. Pseudo traversal. Oh no. We just create another queue for the pseudo traversal. To traverse a priority queue, you create another queue and you like you delete from the source back to the temporary queue. That's how you traverse the priority queue. That's so dumb, man. That's so dumb. So that's a problem, chat. This breaks the algorithm. This breaks the A-star algorithm. It breaks the A-star algorithm because we have these nodes, chat. We have nodes where we store the F-score inside of the node itself. And this F-score stays the same forever. It stays the same. The problem is that we add neighbors to this priority queue. We start from the current position. We start from the current position and we go through the neighbors. In each neighbor, we add him to this open set. Some of them, if this conditional is activated. We add them to this open set. The problem is that if they're already there, we update their F-score externally. We update it externally. The problem is that the priority queue sorts them based on the F-score. And it gets the F-score from the node itself. My plan was to do what gaming suggested. The gaming suggested to remove the element and add it again with the new F-score so that the priority queue can properly update it. It can have properly sorted them out. But the problem is priority queue doesn't have a function for removing an element or for checking if an element is inside of the priority queue. We don't have a function like that. So it's pretty useless, actually. It's pretty useless. Yeah, this is for hostile mobs, but we can use it for non-hostile mobs as well. We can use it for villagers and for cows and sheep, etc. We can do something else, chat. Because the pseudocode here, the A-star algorithm told us we can use something else. Instead of a priority queue, we can use this min heap. Where was it? We can use here min heap. Yeah, this min heap. We can implement a min heap. And we found this implementation of a min heap, where it's actually just a vector. It has a size and capacity. Has a size and capacity. We can insert, we can delete, we can pick, returns the topmost element, removes the root node of the min heap, and heapifies the remaining heap. Oh, but can we remove maybe the min heap has the exact same problem as well. It will be an issue, chat, if the min heap has the same exact problem. Yeah, probably they have the same problem as well. So most likely we will not be using a data structure. Maybe we'll be doing something like this repository that I wanted to avoid. In this repository, what do they do, chat? They have the open set is just a vector. It's just a vector. And while the vector is not empty, they get a reference to the current element. They get a reference to the current element, and they go over all of them. They go over all of them and they pick the one with the lowest F score. Okay, we can do that. We can do that, chat. The only problem is that it will not be of time complexity of log n. That's the only problem. Because here they have a requirement for picking the element with the lowest F score. They have a requirement to be done in log n time, which is faster than iterating over all of the elements. But we're desperate, chat. We don't have much time. Let's do log n implementation. Let's iterate over all of the elements and pick the one with the lowest F score. So we will just use a regular vector. I've decided, chat, we'll use a regular vector. We'll use a regular vector. And we'll have it be a bit slower than what is expected. We'll have it be just a bit slower. So here, let's do std vector of node. And this will be the open set. This will be the open set. This is just push back. This is just push back. And actually, here we can probably just use position details. We can probably just use position details because we don't need to save. We don't need to save the F score. We can just get it externally. We don't need to worry about that. We don't need this, and we don't need this node. We don't need that, chat. We don't need this. So here we push back the starting point. We push back the starting point. Go to neighbor. Here, this is position details. Like that. Like that. So here, what's the issue? Here. Like this. Let's temporarily comment this out temporarily, just to see if everything compiles. Just to see everything compiles. Here we want position details. We'll comment this out as well. We'll comment this out as well, just to see if everything still compiles, and we'll improve it. Okay, chat, this is good. This is good. Okay, chat. How are we going to actually do it? We want to start from the first element. We want to start from the first element. How to point towards the first element of the array? How can we do that? So we can iterate through them. Here they have a begin. Oh, iterator. They just do an iterator, chat. They just use an iterator. That's nice. That's nice. So here we can do auto iterator equals open set begin. They just do an iterator. And we'll go over all of them. So how should we do this, chat? Here we want position details. How should we do it? If I do it like this, it will make a copy. Current node. If I do it like this, it will make a copy. Just a bit of a bummer. And here we can do, this is the iterator like this. Like this. So it will probably make a copy. Can I make a reference? Oh, I can make a reference. Const reference. Yeah, nice. Nice. We can do a const reference. We don't need to make a copy. So now we need to get the node with the lowest F score. We need the node with the lowest F score. So we'll just go over all of the elements. So this will be of time complexity of n, which is a bit slower, but not that big of a problem. Okay, so let's do a for loop. Auto iterator equals open set begin iterator while it's not the end and plus plus like this. And so here we get the current node equals like this. This will be reference. Oh, we have one issue, chat. When a variable is a reference, we cannot change it. We cannot change it to reference something else. I could have this to be just a copy. I could have it be just a copy. Or to be pointer to the node, we'll see. But let's just copy the values. It's not that big of a deal. So here we need to do if. If F score of the node block origin, if the F score of the node block origin is lower than the F score of the current node block origin, we'll swap them. Current node will equal the node. Yeah. So, and we need to update our iterator probably. Do we need a chat? Why would we need this iterator? Why would we need to keep track of the iterator? Why would we need to do it? Why would we need to do it? Where do they use it? Oh, to erase. Oh, to remove it afterwards. Yeah, once we are done with this part, we remove it. Of the open set, we remove it. Interesting. That's the only place we do it, chat. Okay, we can do it like this. We can do it like this, chat. We can move this a bit later. And here we'll just do how should we do it? Let's no, we can call this node. Iterator. Current iterator. Current node iterator. current node iterator. This will be a better name. And here we'll do iterator like this, block origin. And here we do current node iterator block origin. We'll do like this, chat. We'll do it like this. And here we'll, if the F score, we go over all of the nodes. We go over all of the nodes. If we find a node with a lower F score, we update the current node iterator. Current node iterator equals this one, like this, chat, like this. And we'll go over all of them. This is time complexity of n, but it's fine. We're desperate, chat. We're desperate. And here we want if. Here we want if. Let's copy it here like this. So this is the current node. Current node will be current node iterator. So here, if current node equals the destination, done. We end it here. That's it. That's it, chat. Else, what do we do? What do we do else? We go over the neighbors. We go over the neighbors like this. We go over the neighbors. Here we need to give it extra information. We need to give it what? We need to give it, oh, this function. We need to give it the current node and the neighbor. So here we give it the neighbor, but we need to give it the current node. Need to give it the current node. Like this, chat, like this. So nice. So what now, chat? Not what now? When we go over a neighbor, what do we do, chat? When we go over a neighbor? Well, if the tentative G-score is lower than the current G-score of the neighbor, we update his G-score and his F-score. Okay, but we need to add him if he is not in the open set. We need to add him. Now that I think about it, why didn't we use just a set? Chat, why didn't we just use a set? Because here, to check if we have it there, to check if we actually have it, we need to once again iterate over all of the elements, just to see if we contain it or not. So why didn't we just use a set? Because in the set, it's very fast, but unordered set. We can just use an a set, chat. Because a set is made for this, to quickly check if an element it contains it or not. Here, C++ set. Or like unordered set. C++ unordered set. Yeah, unordered set. Let's just use an unordered set. Let's use unordered set. Let's use unordered set. So here, this vector, the open set, let's have it be actually unordered set, like this, chat. And here we need this position details. Oh, it has a hash as well. It has a hash, chat. It has a hash. Position details hash, like this. Okay, nice. We'll use an open set, chat. The code will stay the same. The only difference is when we go over the neighbor here. Sorry, chat. Here we can do to check if it contains it or not. That's the only difference. And checking if it contains or not will be very fast. But here when we push, do we push the start? No, we don't. Here, we don't have pushback. We don't have pushback. Wait a minute. This is an unordered set. It needs to map from one element to another. We're doing pathfinding, chat. We're doing pathfinding. It's not the most fun part, but if we actually implement it, it will be cool. If you actually implement it, it will be cool. So it's worth it. That's why I'm going over this, because it will be worth it. And chat voted it. Like, chat voted for pathfinding, and when it became time for implementing the algorithm, oh no, we don't want to watch what we voted for. That's funny, man. This unordered set is a problem, chat. This unordered set is a problem. Here, I want a set, chat. Set C++. I don't want a map. I want a set. I want a set. Yeah, this thing, chat. I want this thing. So maybe insert. I need to insert it. Insert. Yeah, insert. And we insert start point. We insert start point. Here, let's comment this out. Let's comment this out just to see if it compiles. Okay, it compiles. That's perfect, chat. That's perfect. It compiles. So here, let's when we go over all of the neighbors, we need to check if the neighbor is already in the open set. If it's in the open set, so here open set. I need to invite the cat, chat. Okay, chat, let's continue with the pathfinding. And we have +1. We have +1, chat. A cat will help me with implementing this. Okay, chat. In the open set, we need to check if if we already have the neighbor, chat. We need to check if we have it. So is there a function for find? Yeah, we can do find. We can do find. Can you hear cat? Okay, chat. Here, how to check if an element is in a set or not. How to check? One option is to do find. Using an iterator. That's one option. Use an iterator. But is there a function we can directly use? Like contain. Is there a contains? Contain. Yeah, contain. Oh, nice. Here we need to search for what? The neighbor. If it doesn't contain it, we need to insert it. If it doesn't contain it, we need open set insert. We need to insert the neighbor, and that's it. That should be the algorithm, chat. The only thing is we're not handling the when we reach the destination. That's the only thing we're not handling when we reach the destination. Cat went on expedition. Hopefully she doesn't go on the bed because she's dirty. Should we run it? I think, yeah, let's run it, chat. Let's see what happens. But we need to actually execute the code. When should we execute it? When we place a torch, a redstone torch. Let's run it here. Let's rename it to A star. Bro, what the cat doing? Player. And here we do A star. Like this, chat. A star. So what now? We need to execute it in where? Game layer. In game layer, when we right click. Yeah, when we right click. Yeah, when we place a block. Yeah, block placement. Here I want it. Player, A star, and we do the block we are placing. And what's that, chat? What's that? Where's the block that we're placing? Mission aborted. Bro, the cat went on the pillow, man. She went on the pillow, man. With the dirty paws, man. Bro. She went on the pillow, man. I removed her. Now, I use structs in C++ because everything is public. That's why I use structs. It's just faster. In class, I will need to do public, private, etc. And that's annoying. Okay, let's execute the A star. We'll execute it here from the player. The start will be the player position. The destination will be the block we place. That will be it. Okay, let's test it if it actually runs or if it goes into a while loop. We actually need to do one last step to stop it. We need to stop it here. We need to return here when the current node is the destination. Return. We need to return here. And let's see our beauty. The masterpiece we created. Let's see if we get in a infinite while loop. Let's place a torch here. Okay, it goes in an infinite loop for some reason. Oh, maybe because of yeah, I may know why. maybe because of the starting position, it's using too low of a block. When we create the starting position here, let's add to it a bit on the y. Let's add to the y vector 3. Let's add here 0.5f, just in case. Because our pathfinding doesn't go up and down. It just goes to the left, right, front and back. So let's place an item. It's still the same. We could... let's try to pause it. Call stack. Let's try to do a breakpoint then. Here. Do we remove? We don't remove the nodes. Chat. We don't remove the nodes. That's the issue. Chat. Here we need to do open set remove delete erase current node iterator. Oh, but yeah, we're doing a copy. We're not doing a reference, so it's fine. And let's see what do we get. And we are over the time limit, man. It's a bummer. We need to do creative mode by default. Okay, let's do a breakpoint. To not burn out. It's very simple. How many nodes we have? We have 30 nodes. Let's keep this part. This is the current node. It's 5, 6, and 0. Let's keep this part. So current node now is 460. That's the lowest F score. And we check if we are the destination 5, 6, 15. So the destination is 5, 6, 15. And we are at 5, 6, 0. So we just need to go on the Z-axis 15 blocks on the Z-axis. We just need. So size is 30. We erase it. Size is 29. So this works. We go over the neighbors. So current node 560, and we should go to the north. Here. This breakpoint here. Wait, we don't do breakpoint here, chat? That's weird. Go to neighbor, right? We should be going here, but we're not. That's weird. Why are we not going here? Or maybe because we're in release, it probably does optimizations where it removes this probably, and it does some kind of and we cannot do a breakpoint here, most likely. So what's our best option, chat? What would be the issue? Okay, let's do this, chat. Let's do this. Let's have a breakpoint here. And we'll just take, and let's make it very simple. Let's have the destination be very close to us. Let's have the destination be very close here. Here. Like this. So the set currently has 1 element. Now it has 4. It has 7. 9. Oh, it found it, I think. But probably we're falling down. Yeah, probably we're falling down. Yeah, we're falling down. What I'm curious is why. Let's make it be by default player to be in creative mode. Creative. Let's do it by default to be creative mode. We have one big issue, chat. The issue is that we didn't immediately find it because it was very simple to find. It was directly in front of us, chat. It's the direct neighbors. It shouldn't be struggling finding it. Like this. So we're here. We're here. And we place it here. It's the east neighbor. Is the east. What's the first neighbor, chat? What's the first neighbor? The first neighbor is north. So we'll add it here. North. This is it. North. Okay, I added it to the north. Is the direct neighbor, chat. Is the direct neighbor. So this is the code. We go here. We go over the neighbors. We go over the neighbors here. And like this. This is currently the north neighbor, chat. No, actually, no. This is not currently the north neighbor. We need to actually pick the one with the lowest F score. So current node, what's the destination? What's the destination? The destination is 6, 4, 4. 6 and 4 is the destination. And the current node is 6 and 5. Which is not the best option. It's not the best option because from the open set, we should have the actual destination, which we cannot target here. Yeah, open set here. Look at this, chat. Here we have the actual destination, which should be the current node is 6 and current node is 6 on the X and 6 on the Z. The destination is 6 on the X and 4 on the Z. 4 on the Z. And here in the open set, we have Z4 and X6. We literally have the destination in the open set. And when we're doing this iteration, we're not picking it. We're not picking it. What's the F scores? F scores, how do they look like? How do they look like? 1, 0. Yeah, 6, 4 is 0. This is 1, 0, 0. All of the neighbors are 0. All of the neighbors are 0 F score, which is not correct. Oh, so the heuristic is just not working. So that's the problem, chat. So that's the problem. The heuristic is just not working. Here, this part is not working. This part is not working. Here, when we calculate this probably Manhattan distance. The y should always be 0. The y is always 0. We don't care about the y because we simplified the problem to be just on the x and z axis. The x. How did we calculate it? Tentative score. It's the current node G score, so it's 0 plus 1. So the F score should And what's the default chat? What's the default G-score? Oh, that's another issue. The default G-score is always 0, the absolute minimum. It will never be lower than the 0. It will never be lower. The starting position G-score is 0, and we add 1 to it. So we don't get in here. We don't get in here. Oh, and this thing actually should be here. This should be here, chat. Most likely. Let's go back to the here, to the pseudocode. Yeah. So it's here. So it's inside of the if conditional. That's when we add it to the open set. And also, what should be the default G-score? What should be the default G-score? If it has one. Okay, let's do that, chat. Let's do that. If it has one. Here, if it doesn't have a G-score, to add it. Directly to add it. Here. If G-score contains, if it doesn't contain the neighbor block origin, if it doesn't contain the neighbor block origin, or if it has a G-score and the tentative is lower, we do this part, chat. That should be it. And the heuristic, we haven't used it yet. Now we should be using it. Okay, chat, this should be it. Actually, this should be it. But let's see. We don't know. Yeah, default infinity. But chat, I've made it so if it doesn't exist, we just immediately add it. It will be the same result. It will be the same result with having the default to be infinity. It's the same thing. Okay, let's add here an item and let's see, can we find it? Okay, instantly it ran. Instantly. Let's actually do a breakpoint, chat. Let's do a breakpoint here. If we get here, if the current node equals the destination, let's do that. No. Here we go in infinite loop because I picked a higher y. Chat, let's stop it here. Let's do a console log, trace log log warning found destination, like this, and we return. We'll do also a breakpoint just to be absolutely sure. Okay, chat. If we manage to make it work, we'll visualize the path. Oh, we did. I found it. Current node equals the destination. X is 9, Z is 15. And here destination, it doesn't allow me to see. But probably it found it. Let's now, that's good, chat. That's good. Let's now make it so we visualize the pathfinding. Let's visualize the pathfinding, chat. Let's visualize the path. Let's visualize the path. And let's do a commit. A star pathfinding using set data structure. We have pathfinding, chat. It's simplified pathfinding. It's not on the Y and Z. I've simplified it to be on the same Y. And what now, chat? Now I want to reconstruct the path. And they reconstruct it with this. Oh, it's a map, is it? Came from. What's this? Oh, yeah. Let's search this, chat. Came from. Let's search this. So this is a map where for the neighbor, where for a node, we tell from where we came from. Okay. Okay, so we can do a map here. Let's do a map. Came from map. Let's do an unordered map. Map. It's between. Let's do position details. And position detail. Maybe. Came from. Right, chat? Let me think about it. So we are saving the parents. We're saving the parents. I can do just vector 3, the block origins. I can just do block origins. We'll leave it like that, just to be sure. Position detail hash. We need to give it a hash. Okay, what now, chat? What now? So here, when we go through the neighbors, let's get reference to this. Came from, let's get reference to it. So here for every neighbor, what do we do? If the tentative G-score is lower than the current one. So here we do came from the neighbor equals the current node, like this, chat. Like this, and let's reconstruct the path. The path will be a vector of position details. And let's have it be in the world temporarily. Here let's do static void reconstruct a star path. Reconstruct path. And here we'll get const std unordered map position details position hash. This is the, what's this? Reference came from, like this. The const reference, and we need to implement it. The way I want it implemented is inside of the world data. I'll have a vector here of position details, current path. I'll have a current path. I'll clear it every time. World data, current path, clear. I'll clear it and reconstruct it here, and I'll visualize it. Wait, I could just change the block type. I don't need to save it, chat. I don't need to save it. I can just change the block type on all of the positions. I don't need to reconstruct it yet. We'll do it some other time. Let's look how we reconstruct it, how they reconstruct it. Okay, here is the total path. We do prepend. We don't need to do that. Current came from keys. We iterate the keys. And for all of the keys, came from current. Came from and current. Oh, so we need two items. We need the current node. So this is the destination. Okay, we need the destination. Okay, we can do that. Okay, let's do that. Let's do for all of the elements in the path, let's change them to be some kind of a type. We don't need this reconstruct path thing. We don't need this. So here in the player, what do we do, chat? When we reach the end here, when we reach the end, here we iterate. We iterate here. Should we do it? Here we need to do let's do iterator for how do we iterate the keys? Auto iterator equals came from, can we do keys? Okay, let's iterate begin, and while iterator is not the end, while it's not the end, plus iterator, like this. Sure. And what now? And I want to change the block types of all of these. So to the path, we just prepend current. No, it's different. It's different. While, let's do this, chat. Let's do, how do we do it? Let's do position details. Iter. Path node. Path. Okay, this is it. This is it. Path node. This will be. We'll copy the destination. We'll copy the destination while path while came from contains path node, like this, while it contains it. So here we do, what do we do? Path node equals came from path node, like this. Sure. And here we do path node set block type to be redstone torch. Redstone torch. And we'll set it. And we need to update the subchunk. Set dirty. And that's it. This should visualize the path, chat. This should visualize the path. You should visualize the path. The only issue is it doesn't go up and down. That's what I don't like. It doesn't go up and down. Yo, so that's the path, chat. That was the path. It went here and to the right. Okay, let's do a maze, chat. Let's do a maze. Let's do a maze. Using a netherite. Let's do a maze. Let's do a maze. Oh, we can just remove blocks here. We can just remove blocks. Like this. We'll start from here, but let's make it be confusing. Let's do it like this. Oh, but I need to reach to here. I need to be able to reach to place an item. Let's. Oh, it's when I place any kind of item. It's when I place any kind of item. And it starts searching. Let's make it be only when I place the redstone torch. Here. If block, how do you call it? ID to spawn. If ID to spawn equals redstone torch. Only then to activate. Like this. Just so we can place other blocks. To place another button to start pathfinding. Maybe. We'll just we can just make it be from the creeper position. We can just do it from the creeper position. This is just temporary, chat. Just temporary. So here let's say that this is the destination. I'll place the torch here like this. I'll place it like this, but let's make it complicated. Let's have it here, go towards here, and here it's unbound. It can go for forever here. It can go for forever. It can go here. It can go here. Here is actually a loop. This is actually a loop. Here it's pretty close. Here it's close to the destination, but not exactly. And let's do it, chat. Okay, chat. When I place the redstone torch, it will create a path. Oh, we're not doing collisions. I need to check if it can go to that path. Yeah, this is the shortest distance. Yeah, it cheated. It cheated. Oh, it cheated. The solution to this is simple. The solution is simple. We can... And let's do it from the creeper, actually. Let's do it from the creeper as well. Okay, let's change this. The A star will move it to the creeper. Just so we can do more cooler paths and mazes. Just so we can do cooler mazes. Let's move it to the creeper. Where is the creeper? Yeah, this A star. Let's remove it. And let's have it be creeper. Where's the creeper? Mobs. Creeper. A star here. Like this. And implementation, please. Brother. Implementation. We'll copy the player code. Where is the player? Here. We'll copy the player code. We'll move it to where the creeper is, but this is creeper. Like that. We need to include position details. Position details. Anything else? An order set. Block. Anything else? So what now, chat? What now? Oh yeah, when we go over the neighbors, we need to check if it's actually a block we collide with. Here, how do we do the terrain collision usually? In the player, how do we do terrain collision? I think it was with in the entity code, probably. It will be in the entity code. Entity. Handle terrain collision. How do we check if a block is collidable? If it's last model parent, if it's block. So we need, what do we need? We need the block state, chat. Need the block state. Damn it. Let me think about it. Yeah, only this, chat. I need only this. So let's go to the A star creeper here. When we go over the neighbors. When we go over the neighbors. Here, this. We go over the neighbors. If it has collision boxes and it's the mesh is of block type. If it's a block type, we will return. We don't want to do work here. We don't want to do work here. We ignore this. Block ID, this is neighbor get block type. And get block type needs to be const because it's not changing anything. Const. We get the block type. We want the world. We need to get the block state. Neighbor. We need to get the current block state. Why does it want to change it here? Why cannot not get const? Const. What's the problem? Like this, okay, sure. And what now? That should be it. And let me think about it, chat. Bro, when we summon it, we need now when we right click, we want to call this function, a star function of the creeper. We need access to the creeper. We spawn it through the chat. Bro, I said the limit is 3 hours, we're almost 4 hours. Bro, what are we doing, man? Let's finish this, chat. I was just looking at the time and I saw like almost 4 hours. Bro, let's finish this, chat. Let's go to the UI. Where do we create the creeper? Summon creeper here. When we summon the creeper, we add an entity, the creeper. We add the entity creeper here. We add an entity creeper here, but it's an entity. And oh, let's see. I'm the stupidest person on earth. Let's implement it on the entity, not the creeper, and I'll have access to the A star. I'll just go over all of the entities. I'm stupid, man. Here, A star. Let's give it to the entity. Let's give it to the entity. And creeper. Let's copy this. Let's go to the entity and let's implement it. Like this. Let's implement it. So any issues? No. Okay, perfect. So when we right click, what do we do? I want to go over the entities. World entity. Here I can only add an entity. Let's do it. Let's create a function. It will be a temporary function. Let's call it static void a star. And here we do const position. Destination. And we'll just go over the entities and we'll call this function for all the entities. So here we world like this, a star. So here entity. Where do we entities? Where do we iterate them? Here we iterate them and we call a star. We call a star with the destination like this, chat. We call a star with the destination. And game layer here we do world A star. See if there are any problems. What are the issues? We don't have position details here. We have position details. Like this. See what do we get? Okay, chat. Let's do very quick test. Summon creeper. And let's do like this. Yo. Okay, nice. This is the pathfinding. Okay, chat. Let's try it again. Let's try it again, but this time let's create a maze. Let's create a maze, chat. Okay, here we have the creeper. Okay, let's create a maze, chat. Let's create a maze. So here... like this, chat. So the destination will be very close to the creeper. Here will be the destination. Here will be the destination. Or maybe like this, chat, like this. Here will be the destination. Here will be the destination. He can go here, he can go here, can go here. We can make it even more complex. We can make it go here, like this, chat, although this is even harder, chat. Here will be the destination. Or like here. Okay, let's try this, chat. Let's try it. This is a maze, chat. This is a maze. When I place the redstone torch, it will start searching for it using the A star. Let's test it. What happens? Okay, we found, chat, it found the path. Look at this. Goes here, goes here, goes here, here, here. Perfect. I want to make a screenshot of this. Like this. Perfect, chat. Let me change the thumbnail. Let me change the thumbnail so people know what to expect. Shares, camera, stream. Okay, done. This, save. I changed it. So we're way over the time limit, chat. We're way over the time limit. Let's do a summary of what happened during this stream. So the summary is, first we added the survival inventory. This is the survival inventory where Steve doesn't look at the mouse. He's just an image. But here, this inventory, we can actually use it. We can actually use the inventory, and this inventory syncs with the hotbar below and with the creative inventory as well. Here we have the same items. This is what we did in the first part of the stream. The second part of the stream, chat voted to add mob pathfinding. We implemented the A star algorithm to have the pathfinding. Currently, I made it so when I place this torch, all of the mobs try to find the location to it, a path to it, and they start searching. And this mob, this is the only mob we have, the creeper. It started searching. It went here, 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 and it found the destination. This is not fully implemented because if we go above This is only limited to the Y of the creeper. We have not implemented going up and down. We have not implemented going up and down as of now. This is only, we simplified it just so we can focus on the pathfinding, the A-star algorithm, which is, I'm glad that I'm glad that I simplified it, because if we attempted to do it more complex, going up and down for the path, we wouldn't have done it in time, because even with this simplified version, we run out of time. We're almost at 4 hours, where we usually just do 3 hours of stream. So that's it, chat. We have pathfinding. In here, if I do it here, it found this path. If I do it here, it found this path, chat. If I do it here, it found this path, chat. But if I do it above it, it will go in an infinite loop, because I don't have a limit. It will search then everywhere to try to find it. If it's a place it cannot reach. So that's it, chat. That's it, chat. Thank you for watching, and I'll see you tomorrow. Bye, chat.